Composite functions are a way of working with two different functions, but in this case you put one function into another. So we can write composite functions, there's notation two different ways. The one on the left says f of g of x. So we say that f of g of x. Similarly, on the right means the same thing, and we say the same thing, f of g of x, f of g of x. That means that you're going to put x into the g function, and then whatever comes out, you're going to take that output and put it into the f function. So let's give it a try. We're going to look at some tables first and just kind of get used to what this means. We have f of g of 3. F of g of 3 that we need to evaluate. That means I'm looking for g of 3. Well, I'm going to take this 3 and I'm going to put it into the g function. So I'm going to put it into the g function. G of 3 is this value right here. G of 3 is 2. So when you put that's how this table kind of reads. So let me go back. When you put a 1 into the f function, f of 1 equals 6. When you put a 2 into the f function, f of 2 equals 8. When you put a 3 into the f function, f of 3 equals 3. And a 4, f of 4 equals 1. Likewise, when you put a 1 into the g function, g of 1 equals 3. G of 2 equals 5. G of 3 equals 2. And g of 4 equals 7. So when we're asked to find g of 3 and put that result into f, g of 3 is 2. So that means f of 2. So we're just replacing g of 3 with a 2. G of 3 equals 2. So when we put a 2 into f, f of 2 is equal to 8. Another way that I like to write this is, I just kind of like to use arrows. So I might take an arrow and say I'm going to put a 3 into the g function, and when I put a 3 into the g function, I get a 2 out, and then I'm going to take that 2 and I'm going to put it into the f function, and when I put a 2 into the f function, I get an 8 out. So sometimes I kind of write it with arrows. Sometimes I write it the way I did on the left. It's really up to you, whatever you're comfortable with, and whatever you see, whatever makes sense for you. So let's try g of f of 3. F of g of 3 is 8. F of g of 3 is 8, right? So let's just write f of g of 3 is equal to 8. That was the first thing we needed to find. Now the next thing we need to find is g of f of 3. G of f of 3. G of f of 3, well, f of 3, when you put a 3 into the f function, you get a 3 out. So we're simply going to put that 3 in for f of 3 because that's what f of 3 is equal to. And g of 3 is equal to 2. G of 3 is equal to 2. So that means that g of f of 3, after all is said and done, that is equal to 2. Notice how the order does matter. F of g of 3, I'm going to write this off to the side. F of g of 3 in this case is not equal to g of f of 3. So in this case, those two composite functions are not equal. So the next one we're going to have you try using the table that I have right up above. You're going to use that table and you're going to find f of g of 1 and then g of f of 4. F of g of 1 and then g of f of 4. And when you're ready to check your answers, go ahead and press play. F of g of 1, f of g of 1 is equal to 3, and g of f of 4 is also equal to 3. So f of g of 1 is equal to 3, and g of f of 4 is equal to 3.